Good morning, student. Today I am going to discuss about elastic collision in one dimension. You know that in elastic collisions, total momentum of the system is remain conserved and the total kinetic energy of the system is remain conserved. Also, the total energy of the system is remain conserved. Okay. So let us consider two elastic body of mass m1 and m2 moving along a straight line with a velocity u1 and u2. After some time, they undergo hand-on collisions and they continuously moving along the same directions with the velocity v1 and v2. Okay. Let A and B are two body moving with an velocity u1 and u2. Mass of A is equal to m1, mass of B is equal to m2. Okay. Here you take u1 greater than u2. Okay. After that, they suffer head-on collisions and they continue to move along the same directions. When they separate, at that time the velocity is v1 and v2. So, after collision, velocity of body A and B equal to v1 and v2. Here v2 greater than v1. Okay. Now discuss about the momentum in the system. So according to law of conservation of momentum, First look at the figure. Body A moving with the velocity e1, body 2, it means B moving with the velocity u2. After collisions, A and B moving with the velocity v1, while body B moving with the velocity v2. Okay. So this is the velocities before collision and after collision. The mass of A is m1, the mass of M is m2. It is m1 is m2. Okay. So now about the total momentum of the systems. According to law of conservation of momentum, total momentum before collision equal to total momentum after collision. So total momentum before collision, it is m1 u1 plus m2 u2 for first body and it is your second body. Body A, body B equal to m1 u1 plus m2. Okay. Now m1 u1 minus m1 v1, m2 v2 minus m2 u2. Taking m1 common here, u1 minus v1, and it is m2 v2 minus u2. It is equations 1. Similarly, apply the law of conservation of kinetic energy. Okay. Here about the kinetic energy, total kinetic energy before collision equal to total kinetic energy after collision. So total kinetic energy before collisions is equal to your half m1 e1 square half m2 e2 square equal to half m1 v1 square and half m2 v2 square. Cancelling the factor half in both sides, left side and right side. The equation become now your m1 e1 square m2 e2 square m1 v1 square m2 v2 square. Now you have to arrange this one in this way. m2 v2 square minus m2 v2 square. Taking m1 common, it is become a plus b into a minus b. It is your a plus b into a minus b. Equation 2. Now dividing equations 2 by 1. Dividing equation 2 by 1. Okay. Now it is your m1 e1 v1. It is e1 minus v1 equal to your m2 v2 plus u2 v2 minus u2. It is your m1 e1 minus v1 divided by m2 v2 minus u2. Considering the factors mass and density, so these factors. After that, the equation becomes your e1 plus v1 equal to your u2 plus v2. If you rearrange this one, u1 minus u2 v2 minus v1. So this is the relative velocity of approach before collisions equal to relative velocity of separations after collisions. This is the relative velocity of approach equal to relative velocity of separation. Okay. One of the important equation. Clear? That is equation 3. Now, basically equation 3, you have to find out V2 from this equation and put this value in equation 1. So here, using this equation, here V2 equal to U1 plus U1 minus U2. This is equation 4. Putting the value of equation 4 in equation 1. Okay. So what is that value? Look here. Equations 1. You know that equation 1 is your M1 V1 minus V1, that is M2 V2 minus V2. Now putting the value of V2 here, M1 V1 minus V1 equal to M2. Put the value of V2 here, that is your V1 plus V1 minus V2. This is your V2. Okay. The equation became your M1 V1 minus V1 equal to M2 V1 plus V1 minus 2U2. Okay. Now, we will arrange this in this way. It is your M1 E1, M1 V1, M2 E1, M2 V1 minus 2 M2 U2. Okay. Now in these equations, here our requirement is V1, so you have to arrange in this way. Your M1 E1 minus M2 U2 plus 2 M2 U2, that equal to M2 V1 plus M1 V1. Okay. Then we shift this value in the left side and taking common V1, then here V1 became V1 or V1 M1 plus M2. You take this value in the right side and you take common your U1 here. After taking common U1, it is your M1 minus M2 plus 2 M2 U2. Okay. Now V1 equal to M1 minus M2 by M1 plus M2, that is U1 plus 2 M2 by M1 plus M2, it is your. So this is the velocity of the body A after collision. Okay. So to finding out the value of V2, now I can use the equations. This is your E1 plus V1 equal to U2 plus V2. Here you have to find out the value of V1 and put in the equation 1. It is your V2 plus V2 minus V1. Okay. Now you put this value in equation 1. Here it is M1 V1 minus V1, M2, it is your V2 minus V2. Okay. Put here this value M1 U1 minus your V2 minus U2 plus U1 equal to M2 V2 minus U2. Okay. Now you have to multiply M1 and M2 in both sides, that is M1 in the left side, M2 in the right side. Here your the equation became M1 U1 M1 V2 minus M1 U2 M1 U1 equal to M2 V2 M2 U2. M1 U1 M2 M1 U1 2 times, that is became your V2, it is M1 V2. It is also M2 V2 our requirement is V2. So if you add in this way, M2 V2 plus M1 V2 is equal to 2 M1 M1 E1 plus M2 U2 minus M1 U2. Okay, taking V2 common here, it became M1 plus M2. And here you put that U2 common, this is your M2 minus M1. So V2 equal to M2 minus M1 plus M2, it is your U2 plus 2 M1 by M1 plus M2 into your U1. So this is the velocity of the body B after collision. After collision, the velocity of body B is greater than the velocity of body A. It means the V2 greater than V1. Okay.